This is your Unit 7 test review. So beginning with differential equations, we're going to find the general solution, which means we're going to leave c in there. So I'm going to multiply the 6y squared over, and then multiply the dx over. Antiderivative, this would be 1/3 y cubed, but there's already a 6 there, so it is going to be 2y cubed. And then on this side, 1/2 x squared plus 4x plus c. We don't have an initial condition, so just keep going. We're going to divide everything by 2. And then your last step would be to do a cube root. Now I will tell you, this is going to be, oh, oops, I don't have any white out in here. Can't talk and write at the same time. This is multiple choice, and it's not going to look like that. They're probably going to go through and divide everything by 2. So 1/2 divided by 2 would be 1/4 x squared, and then 4 divided by 2 would be 2. And then they might write c over 2, or they might just write c. C is a number and 2 is a number. You get close enough, you're going to be able to pick A, B, C, or D for your answer. All right, this one's same exact idea, but it's a particular solution, and there's going to be a little bit of trig in here. We're going to divide the y to the other side, and we're going to multiply, what's left over there, 2 sine x. We're going to multiply the dx to the other side. So this is going to be ln y. Over here, we're going to have -2 cosine x plus c. And now we need to go and actually find what c is for our particular solution. So we're going to plug in pi for x and e to the third for y. So over here, we're going to have ln e to the third, just as a margin problem. If you have ln e to the third, ln and e undo each other or cancel out. And so all we're going to have is 3. Also a margin problem. Pi on your unit circle is over here. It's the point -1, 0. Cosine is the x part of that point, so it's -1. So this part is -1 times -2 would be +2. And so that gives us c is -1. So I'm going to recopy this step exactly like it looks, except put in the -1 for the, no, it would be +1. Dang it, I don't have any white out. I'm sorry, +1. Just realized that. 2 + 1 is 3. Oh, deep breath. All right, and then we're going to get y by itself. So we're going to exponentiate both sides. To get rid of the absolute value, typically you would have plus and minus, but this is positive, so I'm not going to put anything. And you would have e to the power of all of this. All right, again, a particular solution. So we have this initial condition. We're going to divide over the y squared. When I bring that to the other side, you can write 1 over y squared, but I'm going to write it as y to the -2. It's going to make it easier for us to do our antiderivative. On the right side, we still have 3x multiply over the dx. So we're going to add 1 to the power. That would make it -1, and then you would need a -1 out front. I'm going to write that as -1 over y. On this side, we're going to have 3/2 x squared plus c. Plug in our initial condition. So we're going to plug in 4 for x, 1 for y. So this side will just be -1. Over here, 4 squared is 16. Divided by 2 is 8. And then 8 times 3 is 24. So sometimes you do have to, fight through that without a calculator. And c is -25. So I'm going to recopy this step exactly like it looks, except with that -25. Now, mathematically, what happens here is this y gets multiplied over, and then all of this gets divided over. So essentially, those two items are just going to trade places. All right, 4. A curve has a slope of 4x minus 1. Derivative means slope, so that's our dy dx. And then this is our initial condition. It's the same thing we've been doing. They just kind of wrote it out with words instead of symbols. The nice thing about this is there is no y, so we're just going to multiply over the dx. I like to put a 1 in front of the dy when I do that. We're going to get y equals 2x squared minus x plus c. Plug in our initial condition. So -3 for x, 5 for y. -3 squared would be 9, times 2 is 18. Minus -3 would be +3. Need to move over here. So we get 5 equals 21 plus c. And so C is negative 16. I'm going to recopy this step exactly like it looks, and then we'll actually be done because Y is already by itself. So that is our answer. All right, here this one is multiple choice. Which of the following is a solution for this differential equation? This is what's called non-separable, so you can't solve this and find your answer. You're going to have to test each of them until you get one that works. For the sake of time for this video, I'm going to go ahead and tell you the answer is D, and we'll work through that. But you can kind of see that there's a negative in it, so you can sort of make an educated guess. If you find the derivative of this, dy dx, it's going to be a product rule. Negative x is the first thing, e to the 4x is the second thing. So we're going to review our product rule. It's first times derivative of the second. That involves a chain rule with that 4 there, plus the second function times derivative of the first, which would be negative 1. So what you would do is test each of these, but you can make an educated guess about which one it is to save yourself some time. Like I see a negative here, and it's going to be something with a negative. And then you can try to match it. So we've got negative e to the 4x. This part right here matches with this part. And then it's 4y. So we've got the 4 there. And this part, this negative x e to the 4x, is this y from the original problem. So this part matches with the plus 4y. So D is our answer for that one. You just kind of test each choice. All right, draw a slope field. I know at 0, 0, we're going to have nothing. Again, this is a Miss Cole's thing. Nobody else does that, but I just bold that point because then I know, like if I leave it blank, I'm going to think I skipped it, but really there should just be nothing there. Everywhere that x is 0, I'm going to get undefined slopes, 0 denominator. Everywhere y is 0, I'm going to have 0 slopes. And then you can kind of do like the first 2 quadrants and reflect them down here, or you could do, these 2 and reflect it over here. However this fits right in your mind. I'm just going to start up here so we go left to right. So this is the point negative 2, 2. If you plug those in, you're going to get negative 1. Actually, same thing here. This is the point negative 1, 2. If we plug in negative 1 for x and 2 for y, we're going to get negative 2. So it should be like more steeply negative. If we plug in negative 2 for x and 1 for y, we're going to get negative 1/2. So still negative, but, less so. And actually, I can just start doing my reflecting. It's going to reflect like this. This is going to be positive. This will be more steep. And there we go. Looks like a firework or something. All right, where would this have 0 slopes? So I'm going to set the thing equal to 0, x, y minus y equals 0. And then I kind of just look at it and think about it. If I do y minus y, I'm going to get nothing. So when x equals 1 is when that's going to come out to 0. Because if you have 1y minus y, that's where you're going to end up with your derivative being 0. All right, so where will this have 0 slopes? Again, I'm just going to take the thing and set it equal to 0. If you multiply over the 6, you're just going to get 0. 0 times anything is 0. Now you can think about factoring this, or you could just, in your mind think like, okay, well, 5 or negative 5. When you get 5 or negative 5, that's when that's going to turn out to be 0. All right, those were our slope fields. Here's Euler's method. So we have, this is our dy dx. We're going to start with 2, negative 1. I'm going to start setting up my table. We want to find f of 3 with 2 steps. So I'm going to make there be 2 steps, and I want to land at 3. So then you kind of have to think about what you're adding each time. And I would need to add 1/2. So this would be 2 and 1/2, 2.5. Or if you like fractions, 5/2. This is non-calculator, so I'm going to put the fraction because if I need to sift through any of this without a calculator, I think fractions are easier to work with. But here we go. We're going to take negative 1 plus our step size, which we just said was 1/2, and then the derivative at this previous point. So if I plug in 2 for x and negative 1 for y, I am going to get 3. So this is negative 1 plus 3/2, or 1 and 1/2, and that's going to come out to 1/2. Don't need this anymore. And then we only have to do it one more time. Whatever we get here will be our answer. So it's going to be a half plus our step size, which is a half, and then the derivative at this point. I'm going to do a margin problem for that. I'm going to plug in 5 halves for x, and then plus the 1 half for y. So these 2's are going to cancel. We're going to get 5 plus a half. So 5 and a half goes right here. I thought I was done for a second, but no. Now I have to sift through this. So this is going to be 1 half plus, now if you multiply fractions, multiply the numerator, multiply the denominator, that's going to be 5/4. I'm going to rewrite the 1 half as 2/4. And so when you add, you get 7/4. Although I feel like that is wrong. Did I mess something up here? Oh, 5 and a half is not 5 halves. I'm not awake this morning. I'm so sorry. And I didn't bring my white out. This would be 11 halves. Jeez Louise. Should restart this video, but I don't have time. All right, so this would be 11/4 plus 2/4, so 13/4. I am so sorry. I can add, I promise. All right, 13/4 is our answer. All right, same thing for this one, except this time we have a table, so I'm not going to be able to mess it up this time because all of my numbers are going to be in my table then. We're going to start at -1, -4. And we want to do a step size of 2.5. So if I have -1 and I add 2.5, that's going to give me 1.5. And if I add 2.5 again, that's going to give me 4, which is where I want to end up. They usually don't ask you to do too many steps, usually just 2 or 3. All right, so let's go ahead and start here. We're going to start with -4 plus our step size, which is 2.5. I'm already regretting that. I probably want that as a fraction. 5 halves, and then times the derivative at the previous point. So when x is -1, our derivative is 6. So that's going to give us -4 plus 6 divided by 2 is 3. 3 times 5 is 15. So that gives us 11 right there. Scribble this out one more time. We're going to take our 11 plus our step size, and then the derivative at the previous point. So when x is 1.5, that is 1. So this would be 22 halves plus 5 halves, so 27 halves. If they write it as a decimal, that would be, what, 13.5, 13.5. All right, our exponential model. This is your PERT formula. A dose of 500 milligrams of medicine is administered to a patient. So let me go ahead and just write out what I've got to start with. The rate at which the medicine leaves the bloodstream is proportional to the amount present. That's a sentence that just means this is an exponential model. Write a possible. I wrote possible because this is multiple choice, and it's which of the following could be this. Basically, you just pick the one that's exponential, like the one that follows this formula and has a 500 in there. Equation for the amount present. The only thing is your rate, this K value, is going to need to be negative because the medicine is leaving the bloodstream. It wouldn't be leaving very fast, so I'm going to make it like negative point something small. We'll just say like 0.2. Right? And that's a possible equation. As long as this is negative, then you're good. And then piggybacking off of that, using that equation, write a differential equation for the rate. Okay, it's proportional to the amount present. Proportional to the amount present. So our dy dt is going to be that negative 0.2 times y. I used Y. They might use M for medicine or G for grams or milligrams. I don't know. They might use a different letter of the alphabet, but you'll be able to pick these. All right, and then our logistic model. What is the limiting value? You just have to know what this formula looks like and pick out that 1700 is your carrying capacity or your limiting value if you did a limit to infinity. That's it. That's a simple one. All right, a fox population follows a logistic model. It is increasing most quickly when there are 400 foxes. What is a possible differential equation to model this solution? So this means that your inflection point is when there are 400 foxes. So if you think about our logistic model, your 400 is right here, and that's half of your carrying capacity. So that means our carrying capacity, our limiting amount is 800 fluxes. So when we go to write our equation, and it's going to be multiple choice, so you'll just have to, read through your choices. And also, again, this says what is a possible differential equation. I don't know what this K value is going to be out front, so I'm just going to make something up. Usually it's a fraction. I'm just going to say 1/10. So 1/10 y, and then 800 minus y. Again, I don't know what that is. We didn't have enough information to find it. So it's what's a possible equation. You just have to realize that this 400 is your inflection point. 800 is the number that should go in the equation. And usually there's a couple equations that don't even follow this pattern, and you can just throw them out right away. All right, rate of change of the amount of water pouring into a swimming pool is modeled by a logistical differential equation. Carrying capacity is 300 gallons. So let me just go ahead and write that out to start with. dy dt equals ky times 300 minus y. So that is where the 300 goes. At a certain time, doesn't matter when, the number of gallons in the pool is 200, so y is going to be 200, and is increasing, so that's our rate, at 20 gallons per minute. So 20 is going to be this dy dt. We said our amount is 200, and then if I plug in 200 here, 300 minus 200 is 100, and we're going to just solve this. I can cancel out 1 0 on each side, and so this is going to be 2 divided by 2,000. Which if we reduce that would be 1 over 1,000 is our K value. So writing out our differential equation, it's going to be 1 over 1,000. And see, that's the value that I didn't know here because we didn't have enough of this other information to find it. So it'll look like that. And again, I used Y. They might use F for foxes. Or, oh, sorry, this one was about water. They might use W for water or something like that. So, yeah, but it'll be multiple choice. All right, so now we are getting into our free response. Sketch a slope field. So at 0, 0, we're going to have nothing. When x is 0, we're going to have 0 slopes. Oh, whoops. Oh, my goodness. Should be right here. When x is 0. I even said that out loud. And I don't have white out. Oh, I'm so sorry. When y is 0, we should have vertical slopes. These should be vertical. I am so sorry. Take your AP exam in pencil. That's the big takeaway from this video. Write with pencil. Do not write with pen. Okay, now we're going to have to kind of slog through one at a time. But what I get over here is going to reflect. So if I do this half of it, I can just take those slopes and reflect them. So it won't be too bad. So here we have -2, 2. So if x is -2, that's going to make that 10. If y is 2, that would be 4. 10 fourths. Would be, kind of close to 2. So something like that. Again, this is not going to be perfect. It's going to be good enough, right? -2, 1 is going to give us, -1, 2. So x is -1. We're going to have 5 fourths, which is actually pretty close to 5 fifths, which would be 1. So something like that. So less steep than this one. All right, -2, 1 is going to give us 10 over 110, which is going to be like practically vertical. And the lights in this room in the library just, I guess, timed out. Let me turn them back on. There we go. All right, and then here we have -1, 1, which is going to give us a +5. So like somewhere in between those, it gets kind of difficult at a certain point, but again, just good enough. All right, -2, -1 is going to, again, give us 10. That squared makes that not change because if you square a negative or a positive, it's going to come out the same. All right, -1, -1 is going to give us 5, so it should look kind of the same as that one. -2, -2 is going to be our 10 fourths, so 2, so kind of like less steep than either of those. And then this one's going to come out the same as well. And then I'm going to take those and reflect them over here. So see how good of a job I can do here. This one's steeper. This one's really, really, really steep. And there, good enough. You got to just kind of trust the process. All right, write an equation for a tangent line. So you need a point, which is our 2, -1, and then you need your slope at this point. So we are going to plug 2 in for x, negative 1 in for y. So that is going to give us negative 10. We're going to write our equation. And then we want to plug in 1.9 for x and get y by itself. So y is approximately negative 10. Then we're going to plug in our 1.9. And then to get the y by itself, you just have to subtract that 1 to the other side. I would like to see nobody miss that. That's super easy. You plug in these numbers to get your slope. You write an equation, and then you plug in the number you're approximating. That's all there is to that. And then here you're going to solve it. So we're going to multiply over the y squared, and then multiply over the dx. Antiderivative, 1/3 y cubed. On this side, we have negative 5/2 x squared plus c. We're going to plug in positive 2 for x, negative 1 for y. So that's going to give us negative 1/3 equals 2 squared is 4. 4 divided by 2 is 2 times negative 5 is negative 10. And then you're going to add that 10 to the other side. So we would have negative 1/3 plus 10, which would be 30 thirds, which is going to give us 29 thirds for our c value. I'm going to recopy this line right here. And then to solve it, we're going to multiply by a 3. So you're going to have 3 times all of this. And you don't have to worry about simplifying at all because this is free response. And then we're going to do a cube root. And you can leave it alone. You do not have to simplify that at all. In fact, don't. That's how it'll be on my answer key. All right, and then this one is, it's kind of like a related rate, sort of a word problem that involves a differential equation. Water is being poured into a cylindrical container. Radius is 3, height is 30. Those aren't changing. The cylinder isn't, magically growing. The height of the water is given by h of t, so h for height in centimeters, time is in seconds. Volume is changing at a rate of this, so that is dv dt. So your volume is changing at that rate. So show that. All right, so they're saying this is the answer. You just need to prove it. Oh, also, on your test, they give you the volume of a cylinder. It's pi r squared h. So that'll be written, in the problem. So we're going to start with that. Now we know the radius of our water is going to be the same as the radius of the cylinder. Water takes up the space that you give it. So radius is 3. 3 squared is 9. So 9 pi h. Now the height of the cylinder is not changing. That's, 30? But the height of the water is changing. To give you a visual, and don't make fun of my picture here. So the height of the cylinder is 30. That's not changing, but the amount of water in it, this is our H value. We're filling the cylinder up. We're filling this cup up with water. So that height is changing. The height of the water is changing. So you can't just plug 30 in for that. The cup isn't full all the time. All right, and then we're going to do our derivative. So this would be 9 pi dh dt. We have dv dt, it's this. So we're going to plug that in for dv dt. And then we're going to solve for dh dt. Conveniently, these pi's cancel. All we have to do is divide over the 9. And if you check, that is what we were supposed to get. So you have the answer ahead of time. You're just showing that. You're kind of proving that that is what the answer is. All right, given that height is 12 centimeters at time 0, so we're starting out with this height of 12 centimeters of water at time 0 seconds, solve this differential equation. So we're just solving a differential equation with this being our initial condition. They just kind of made a story problem about it. Now this is h to the 1/2, so you can think of this as 2/9 h to the 1/2. First thing you want to do is divide that to the other side. So when you bring it over, it's going to be negative 1/2. And then on this side, you have 2/9 dt. Now, the nice thing about that is when you add 1, it's going to become positive 1/2. So it's not negative anymore. And we need a 2 out front. This side will be 2/9 t plus c. We're going to plug in our initial condition. Conveniently, time is 0, so that all just goes away. And then our height is 12. You can write 2 times 12 to the 1/2. I'm just going to write 2 square root of 12. I think that looks nicer. We're going to recopy this step. Actually, I'm going to write that as square root of h. You can write h to the 1/2 if you want, personal preference. And then you just have to get h by itself. Do not simplify any of this. It's your grader's problem to figure out if it's right or not. That's me. That'll be my problem. I'm going to divide over this 2. And then to get rid of the square root, you need to square all of it. And just don't do a copy error, which I'm hopefully not doing. At what time is the container full? Just as a heads up, I made this the opposite of the way it is on your test. It's going to say at what time is the container empty. That's going to be a whole lot easier on your test. And I always try to do that. I try to make this study guide harder than the test. If you want when the container's empty, you take your height and set it equal to 0. 0 is a much easier number to work with. This says at what time is the container full. So we're going to take this height that we got, and set it equal to 30. The height of the cylinder was 30. So when the height of the water is 30, we know that it's all the way filled up. And then we're just going to solve this. Again, this is going to be way messier than the one on your test, because if you set this equal to 0, the first thing we're going to do is square root. Square root of 0 is just 0. I'm going to get square root of 30, right? So we'll have 2/9 t plus 2 square root of 12 equals, I'm going to have square root of 30. And then to get rid of this dividing by 2, I'm going to multiply that 2 to the other side. I'm going to subtract over this 2 square root of 12. And then the last step, to get rid of the 2/9, I'm going to multiply by 9/2. So 9/2 times all of this. Again, yours is going to look way nicer on your test because if you set it equal to 0, it's just going to turn out a whole lot nicer. All right, and then here are our calculator questions. So we're given this slope field. We want, particular solution through 0, 1. That's our initial condition. H of x equals this thing. Find h prime of 0. So we're going to find h prime of x, and then we're going to plug in 0. This is a product rule. We're going to have the first thing times derivative of the second plus second function, and then derivative of 8x is just 8. And then we're going to use this slope field to start plugging things in. Now, if we plug in 0, 8 times 0 is just 0, so it kind of doesn't matter what this is. Can't remember how this turns out on the test, though, and you might actually need this number, so let's go through it. We want our derivative or our slope at 0. Now, I realize, this is 1 and this is 2, but you can just use these, miniature guidelines to find it. Your slope at 0, and all of these are the same, is you go down 1 over 2, so negative a half. And they're all the same, and they're going to have to all be the same on your test, wherever x is 0, because otherwise, if they were all different, you couldn't get an answer for them. All right, and then we want f of 0, which they tell us is 1, and then times 8. So this whole thing is 0, that goes away, and so your answer is just 8. So we didn't even need the calculator. You'll find that they do that a lot. They allow you a calculator on ones where you don't even need it, and then on non-calculator ones, you're like, wow, it would be nice to have a calculator. All right, during an epidemic, number of people that are infected increases at a rate proportional to the number of people. That is a sentence that just means this is exponential, right? 1,800 people are infected when it's first discovered. So we're going to start with 1,800 being our initial condition. 2,300 people are infected 8 days later. So 2,300 goes here. We're going to put in 8 days for time. And then we're going to start solving this. So I'm going to divide over the 1,800. Actually, first I'm going to cancel out my zeros here. So 23/18 equals e to the 8k. And I'm going to hold off getting out my calculator until I'm all ready to type this in. To get rid of e, we're going to ln both sides. And then your last step would be to divide both sides by 8. So now I'm going to share my screen. We're going to come over here and we're going to type in ln 23/18 and then divide that by 8. So we get that decimal for our rate. You can notice it's positive, and that's because the amount of people being infected is increasing. I guess you can kind of see my paper here at the same time. All right, and then we want to know how many people are infected 12 days later. So what I'm going to do is type in my initial 1,800, e to the power of this rate, so I'm going to copy paste it and then multiply it by 12 days for That's what it asked for. All right, so we're going to round that to 2,600 people. And it's multiple choice on your test. All right, last one. Number of bacteria in a culture in grams is decreasing according to this differential equation. You want to notice this is K times Y. This one is exponential. And then there's another culture. I actually really like this question because it's compare and contrast. Another culture decreases according to this exponent. This, it's not exponential. Take two. Differential equation. This one's not exponential. Notice how this is a constant rate. If you have a constant rate, that means that is linear. So we have one that's exponential and one that's linear, and we're going to write two equations for them, one for A and one for B. So at time 0, the first culture has 5. So that's exponential. It's going to be 5e to the power negative 0.3. And I'm going to put x because we're going to use the calculator. You can write t, but when we go to Desmos, you're going to have to type x. All right, and then the second one has initial condition of 7, and its rate is negative 1.5. So negative 1.5x plus 7. This is good old y equals mx plus b. So exponential, linear. I love that. You have to know the difference and write an equation for both of them. It's a really good question. At what time are they the same size? So what we're going to do is go to our calculator and type them both in and find where they intersect. Oops. So first one is...
This is your tuning and running. This is your tuning and running.
So, and see how it's an exponential decay? It's like a little swoopy thing, but it's swooping downwards. They said the amount of bacteria is decreasing. All right, and this is our answer right here. Time is 3.5, whatever it was, days or hours. What did they say it was? 3.5 hours.